Good evening, guys. Good evening, everybody. Welcome to my working room. My name is Hasan Zeki Alp. I will be presenting you Seaborn programming language lessons in English. Actually, I have made an introduction in my native language. However, I decided, I made up my mind and decided to prepare a video course that could be spoken in English language. So just my intention is to give some hints and some clarification, some explanation about Seaborn code. I'm talking about a module for data visualization for Python programming language, in fact. I have already prepared some sample codes, some example codes to present you how powerful Seaborn is. And for presenting you, for displaying all this stuff, I will be using a utility, of course. This utility is Anaconda companies, corporations, Spyder utility, Spyder integrated development environment utility. Frankly, I have been in a hesitation on deciding on the development environment. In fact, I just considered other Python development environments. However, just since I have become much more acquainted with Spyder rather than other than programming development environments. Just we will be using Spyder IDE environment, I integrated development environment I am talking about, and I will be following the contents of such different websites, but primarily tutorials.com will be the first one that I've been implementing, utilizing to get codes, to show you codes. And right away, I'd like to start up by sharing my screen share program. And I'm already prepared to show you this. Okay. Just as I said, Seaborn, we will be presenting you. I will be presenting you. Seaborn data visualization program can be used to make much more clear the contents of any data sets, any bunch of statistical data or numerical data, just I can say. Let's start with the very first example for being familiar with Seaborn and its capabilities. And here, just I opened just before I opened a file. That's Seaborn demo 01 file. As you can see, I here import a Seaborn module, and I import it as SB. That means so I can use the available commands or available methods by mentioning just the letters SB instead of mentioning Seaborn. And here I recall a method here, and its argument is sb dot get datasets names. This is a prominent, just I can say, library, a whole bunch of information, and just I would like to get it printed, and after that I'd like to get an idea about Seaborn commands or Seaborn methods by mentioning help, open parentheses, and SB and close parentheses, and I want to make it printed. Okay, let's have it run and see the result for this very easy example. Okay, just I can show you here. Okay. Yes, that's what I want to show you guys. This is scomp, attention, brain work, networks, car crashes, diamonds, dots, exercise, flights, fMRI, gammas, and iris. Okay, iris, that's gonna be used by ourselves. Iris. What I'm showing you is that available data sets that I can implement, that I can utilize in order to show you much more examples. And there is a few empty lines here. And after that, I use print method once again in order to display you the contents of help regarding for SB. And here, just you can see available commands, algorithms inside of this package. There exist algorithms, opinions, axis grid, categorical, colors, matrix, palettes, and just I said, linear models, palettes, RC mode, regression, relational, etc. etc. So by using this structure, just we can get an idea about available data sets. Okay, and after that, let me show you another example. Okay, yes. Okay, just I would like to make it a little bit greater. Okay, just as I said, in order to use NumPy module or another module that regards with Python, I have to import it at the very beginning, right? And I have to import it by using an keyword as so I can abbreviate its number, or I can dedicate a special code for that. It's commonly used NP for NumPy, and it's commonly used for PLT for PyPlot. That's a member of Matplotlib library. And here, this is the main structure of this code snippet, you guys. I here define a synplot function. Okay, just how do I understand this? By this Collins says me that this is a function definition, and it has an argument. Philip, it's gonna be a first. It's gonna be one as initializing value, and here I define another variable such as x. X will be assigned as mp dot line space and with these parameters. And the first parameter stands for the initial coordination of this coordinate system, or the zero of our coordinate system. And what stands for 14? 14 means the ultimate right, the right word, the utmost right value of our axis, or maximum value of axis, and 100 stands for the resolution of our graph. The more numbers means more resoluted, high resoluted graphs, in fact. Otherwise, it's gonna be cracked lines. And I here define my plot function. It's gonna have an x component, and it's gonna have an mp dot sin x, or sin u function recalling, function invoking. And just focus on here, you guys. X stands for angular velocity, in fact. And how about this 0.5? 0.5 is added to the variable to sine that is called as phase of this sine function. This is expressed in radian units. So it's about a half of pi, that means 3.14. And what stands for this? This is a magnitude or amplitude coefficient. And what stands this? This is flip. Flip will be increased as so as to scale our graph as overall magnification. And how about this one? Sorry. How about this one? Just focus on here, you guys. For in loop. By means of this for in loop, I want to repeat this sign drawing for 5 times, starting from 1 to 5. So just we can comprehend that, just we can consider that there will be 5 lines so as to be drawn on the screen by some phase differences. Okay, this is the phase difference 0.5, and this is the end of our function definition. Okay, and this starts with Seaborn module import, and I abbreviated as SB, and so after this line I can use SB dot set. Set starts with to initialize the coordinate system, and I invoke this synplot function. Okay, just as I said before, this is a function definition, and here I invoke it, I recall it without any arguments, in fact, and plt.show just completes the scene so as to be displayed on the screen. And I just simply make it run this code. Okay, and I simply make it undocked so as to present you much more in detail. Just as I said, this is a sine wave, and just I can say that you guys, it has a phase difference because there exists a number here. Without this number, just we could say that sine curve starts with the conventional limits, in fact, but by seeing this, just I can say that okay, it is already started with a phase difference. I can see here phase difference because it's already start here instead of starting here. Somehow it's shifted a little bit left. And what can I say here? It's 0 to 14. It's already here like this. Okay, starts with 0, the very first axis, and this is the maximum axis, and this is the magnitude maximum value, and how about this one? And this is the minimum amplitude value, and that's it, you guys. I hope it's clear enough to comprehend this kind of plot method usage. And I will show you another example here. Okay, this time, okay, this is much more sophisticated one. This time, rather than just one a constant, using a constant phase difference, I use it as a multiplication of as a folded by an independent variable I. This is the counter for in loop, and just I have another magnitude coefficient here. It's not a constant, as you see. It's already start with 7 minus 1, so that starts with a magnitude of 6 units, and after each step, let me say at the end of this for in loop, is this I counter will have a value of 5. In fact, 5 means 7 minus 5, that means 2. So just I can say that 2 units will be a magnitude of this sine graphic. Just the other parts are almost the same, and I simply use sin plot, and I use PLT show, and let me show you this time. Okay. Okay, just as you can see, we have here 5, 1, 2, 3, 1, 1, 2, 3, 4, uh, 4 different phased signs, and starts with 0, and the maximum axis numbers is 14. Just I can see here I use a resolution coefficient of 100 so as to be a nice view graph, in fact. And how about 6 and minus 6? Just I said 7 minus 1 means 7 minus 1 means 6. So plus 6 minus 6 will be our sine waves, ultimate waves, peak to peak value is gonna be 13, 12 in fact. And just what I say, what else? Okay, flip. Flip is overall magnitude or overall scaling factor. Just by saying flip, 1, so just I can say that this scale will be 6, and how about let me make it 10, for example. Let's say like this. Okay, it becomes 60. Actually, the magnitude of sine wave also will be increased, and that's one of the examples that I want to show you guys. And just for the sake of overcome uploading problems, I have to stop this at right this point, you guys. And if you like my presentation, you can be subscribed to my channel, you guys. And from now on I will show you in my next lessons the usage of Seaborn commands, Seaborn methods. And thanks for your sharing time, and thanks for your sparing time for me. Bye bye, have a nice evening.